When we're measuring the variability of a skewed distribution or a distribution with outliers, we're going to use what's called the interquartile range. So this is a better choice when we're describing variability for a skewed or distribution with outliers, because this, like the median, is resistant to the effect of outliers. We'll often see the interquartile range abbreviated as IQR, either uppercase or lowercase. And it's based on these quantiles that we call quartiles. I know it's a little confusing, but quantiles is just where you split up your distribution based on different percentages. Quartiles is a specific case where you have split your distribution into quarters, each with 25% of the data. So the lower quartile is going to be looking at that smallest 25%, and then the upper quartile is going to separate the largest 25% from the smallest 75%. So you're looking at basically the 25th and the 75th percentile here of your distribution. So it's giving you the middle 50. And here you can see a picture here. Your lower quartile is there at the bottom between the lower 25 and the upper 75. The upper quartile is there at the top with the upper 25 and then the lower 75. The median is right in the middle, 50% below, 50% above. So the interquartile is going to contain this middle section, this middle 50% from the lower quartile to the upper quartile. So by definition, your lower quartile is essentially just the median of the lower half of the data set. If you look at the lower 50%, it is right there at the middle or the median. The upper quartile is the median of the upper half of the data set. Now when n is odd, the median is going to be excluded from both halves if you're calculating these by hand. If n is even, then the median wasn't actually in the data set to begin with, and so you're just going to look at the bottom half. Your interquartile range is easily calculated by taking the upper quartile minus the lower quartile. This is also done incredibly easily using a software program like StatCrunch. So when our standard deviation was measuring the variability in terms of how far the observations tended to fall from the center, the interquartile range, by comparison, it's still looking at the variability, but it's just looking at how spread out the middle 50% is. So even though those are similar descriptions, the standard deviation is actually including the values of everything in the data set, whereas the interquartile is just looking at that middle 50%. So if your middle half is all really close together, you're going to get a small IQR, and you'll know that from that small value, and that's going to tell you that you don't have a lot of variability. But if your interquartile range is large, that means the middle 50% is really spread out, and so that you know that the variability here is big, and not because of extreme values, but because the middle 50% is really that spread out. If we take a look at the example 3.8, where we used the center for the median of the website data distribution, we can calculate our interquartiles by separating the lower half and the upper half. Now here, remember, even though the median was 13, which was a value in the data set, we didn't actually use the 13 in the data set for calculating the median. So we'll take our lower 20 numbers and our upper 20 numbers. Here, the median of those lower 20 numbers is 4.5. Since we have a 4 and a 5, we average them to get 4.5. And then the upper half, we have 20 and 21 there in the middle, and so the upper quartile is going to be 20.5. We would then calculate the interquartile by subtracting those two values. 20.5 minus 4.5, the interquartile is 16. Now, here we know that since that lower quartile is separating the smallest 25 from the rest of the data, then we know for sure that 25% of the students viewed the website less than 4.5, since our lower quartile was 4.5. We can also say that 50% visited between 4.5 and 20.5, and we can say that 25% visited more than 20.5. So these quartiles are very helpful for you to split up the data lower 25, middle 50, and upper 25. With this IQR being 16, given the types of values that we have in our distribution, that's a pretty big number. So here we see that there is quite a bit of variability in the data set. But as a comparison, the standard deviation here would have been 52.33 because of those two outliers. And so at least we're not thinking that the variability is quite as extreme as we would have had we reported the standard deviation. We can also go back and look at the medical error data where most of the doctors didn't have any errors, but there were a few large values. So we would certainly want to use the median for calculating the center for this distribution, and in this case, it's 0. We split up the data, and so we see that the lower half has a median of 0, so our lower quartile is 0. Our upper quartile would be 1, looking at the upper values and finding the median there. So here our interquartile range is 1 minus 0, so we only have an IQR of 1. That means 50% of the values were there between 0 and 1. So we would see much more clearly that most doctors are not making any mistakes. 25% aren't making any, the middle 50% are making between 0 and 1, and it's the upper 25% where we're having our problems. It's nice to think of these numbers grouped into quarters for these quartiles, and you can see the 25% in each group. So having such a small value for the interquartile range tells us that there's not a lot of variability in this data set. If we had done the standard deviation, we would have gotten a much larger value, and that would have not reflected what was actually going on with the distribution. So if we put this all together, looking at now that we have both a symmetric and skewed data, when we have skewed data or outliers, then we would select our appropriate measure of center and variability, and in this case, we would use the median. We would calculate the values of the selected measures, you would use the median and the IQR, and then we would interpret the values in context. The key difference here is just the type of measurements that we're using compared to what we did when we had symmetric data. So this is data from 50 states and the District of Columbia, giving the percentage of the adult population that has a bachelor's degree or higher. If we were to create a histogram, we would end up with a graph like this. Now, what we do notice here is it is somewhat skewed, and we have that outlier there in the between 48 and 50%. So using the median and the interquartile range is a better choice here so that we aren't going to be influenced by those extreme values. So if you were doing this, you would put all of those data into a computer program, because if you were doing this by hand, you'd have to put all the numbers in order as well before you even did this. And that can be really time consuming, and it's just not necessary for what we need to do in this class. But if we were to order this, we could split with the lower half and the upper half. And in this case, the lower half would give us a median of 26.4. So that is our lower quartile. We look at the upper half and we get our upper quartile of 32.8, and the median is there at 28.7. So the interquartile range is computed by taking the upper quartile minus the lower quartile, giving us 6.4. So with a median of 28.7 and an IQR of 6.4, then the interpretation that we could make is that for half of the states, the percentage of the population with a bachelor's degree or higher is less than 28.7, since that's our median. For the other half, more than 28.7 of the population have a bachelor's degree or higher. Having an interquartile range of 6.4 tells us that the middle half is spread out only by 6.4 percentage points. So it lets us see where the middle is, how that separates our data, and that interquartile range is giving us a sense of the spread of the middle 50%. Even though when the data distribution is approximately symmetric that we've recommended using the mean and standard deviation, we only do that because they are the most commonly used. It still would be okay to use the median and the interquartile range for approximately symmetric data. And we'll see in a later chapter that when the data distribution is approximately symmetric, the mean and the median are going to have a very similar value. And you still can describe the variability with the interquartile range. But you should not use the mean and standard deviation when you have skewed or noticeable outliers. So keeping in mind that the mean and standard deviation, while they are a common and useful thing to use, they are greatly affected by extreme values. So you're going to mislead your readers if you use them in those kinds of situations.